Morning everybody. Today my topic is hybridization in the PCl5 and SF6. Hybridization in the PCl5 and SF6. It is a very important 4 marks question in the IP examination. That's why I am taking this one. PCl5 I am taking, which is called the phosphorus pentachloride you are having, and the central atom is the phosphorus whose atomic number is the 15, and the valence electronic configuration if you observe 3s2, 3p3 and 3d0. Orbital configuration if you observe 3s2, 3p nothing but px orbital, py orbital, pz orbital, and 3d will have the 5 orientation vacant orbit. Now in the valence shell if you observe we have only 3 unpaired electrons, that's why it can form only 3 bonds, but 5 chlorines are there. That's why ultimately in order to form the PCl5 you require the 5 unpaired electron. How it is possible? Whenever you supply the energy, immediately the electron which is present here jumps into the d orbital, then you will get the 5 unpaired electron, then it undergoes the hybridization. So which is called the first excited state. The electronic configuration of the phosphorus in the first excited state if you observe, so this electron jumps into the d orbital. So like this. Now 1, 2, 3, 4, 5. In this excited state, it undergoes the suitable hybridization which is called the sp3d hybridization, which gives you the 5 sp3d orbitals. Now phosphorus undergoes the sp3d hybridization, and these 5 sp3d orbitals which contains the unpaired electron, 1 electron, they overlaps with the 5 chlorines pz orbital. Pz in the chlorine if you observe pz 1 you will get. Each chlorine will have 1 pz orbital. 5 chlorine will have the 5 pz orbital, nothing but this 5 sp3d orbital overlaps with the 5 chlorines pz orbital through the internuclear axis, and they gives you the 5 sp3d pz sigma bonds. 5 sp3d pz sigma bonds. Ultimately, in the PCl5, the central phosphorus undergoes the sp3d hybridization. These 5 sp3d orbital which contains the 1 electron, they overlaps with the 5 chlorines pz orbital. Ultimately, they gives you the 5 sp3d and pz sigma bonds. Ultimately, the shape of the molecule is the trigonal bipyramid structure. And the structure if you observe, this is the structure of the trigonal bipyramid. Phosphorus will be the central atom, and we have the 5 chlorines, 1 chlorine from here, 1 chlorine here, third, fourth and the fifth. This is the shape of the molecule. What is the bond angle? Look at here. This above and the below, they are perpendicular. That's why the 2 angles is the 90 degrees, and remaining these triangle 3 angles will be the 120. Ultimately, any molecule which undergoes the sp3d hybridization which will have the trigonal bipyramidal structure, angles are 2 angles, one is the 90 and the one is the 20. One time in the MCET examination he asked like this. One molecule in which the central atom undergoes the sp3d hybridization, the bond angles are A, 2 angles 90, 3 angles 120. B, 3 angles 90, 2 angles are 120. C, 5 angles 90, D, 5 angles 120. So this is also important. Ultimately we can say above and below the plane they are perpendicular. That's why 2 angles are 90, remaining 3 are the 120. As PCl5 undergoes the sp3d hybridization. The shape of the molecule is the trigonal bipyramid. This is the trigonal bipyramid. Now I am taking the sulfur hexafluoride. Now I am taking the central atom is the sulfur, whose atomic number is the 16, and electronic configuration, valence electronic configuration if you observe 3s2, 3p4 and 3d0. Orbital configuration if you observe 3s2, p orbital will have 3 orientation, 1, 2, 3 and the 4th electron, d orbital will have the vacant orbital. Now in this excited state if you observe how many unpaired? 2, but we require the 6. 6 fluorines nothing but you require the 6 unpaired electrons, then only it is possible. So by giving some amount of energy which is called the first excited state. First excited state. In the first excited state what happens? This p electron jumps into the d orbital. Ultimately electronic configuration, valence electronic configuration is like this. So this electron jumps here. So 1, 2, 3 and this electron comes here. Now how many unpaired electrons? 4. In this excited state how many bonds it can form? Only 4, but we require 6. That's why now by supplying some amount of energy which is called as the second excited state, So by giving some amount of energy, what happened? This s electron again jumps into the d orbital. Now, in the second excited state, electronic configuration is, look at here. So this s electron jumps into the d orbital. Now you observe. How many unpaired? 6 unpaired electrons. Now it is ready to form the sulfur hexafluoride. In this second excited state, 1 s orbital, 3 p orbital, 2 d orbital submerges with each other to give 6 sp3d2 hybrid orbital. 6 sp3d2 hybrid orbital. Now, this 6 sp3d2 hybrid orbital, which contains the 1 electron, they overlaps with the 6 fluorines. Each fluorine will have the pz orbital which will have the 1 electron. 6 fluorine will have 6 pz orbital. They overlaps with each other and they gives you the 6 sp3d2 pz sigma bonds. 6 sp3d2 pz sigma bonds. Ultimately, the shape of the molecule is the octahedral. Any molecule which undergoes the sp3d2 hybridization, the shape of the molecule is the octahedral. What is the octahedral? So this is the shape of the molecule. Central atom is the sulfur, and we have above plane and the below plane we are having. So fluorine, how many fluorines we have? 6 fluorines, and this is the shape of the molecule which is called as the octahedral. Immediately, what is the bond angle? If you observe the bond angle, these are the right angles. Whatever this angle is also right angle. Ultimately, angle is the 90 degrees. Nothing but all the 6 angles is the 90. In PCl5, if you take, 2 angles are the 90, 3 angles are the 120. But in case of the sulfur hexafluoride, which undergoes the sp3d2 hybridization, because it has the 6 unpaired electrons, so 1 s orbital, 3 p orbital, 2 d orbital intermixes with each other to give 6 sp3d2 hybrid orbital. These 6 sp3d2 hybrid orbital, which contains the 1 electron, they overlaps with the 6 fluorines 2 pz orbital through the internuclear axis. Ultimately, they gives you the 6 sp3d2 pz sigma bonds. The shape of the molecule is the octahedral. Bond angle is the 90 degrees. Thank you.